So before we execute those commands, yeah, I want to explain a few things regarding this Kubernetes. Did I explain? Okay. Did I open this document? Did I explain anything from this document?
No, sir.
Okay.
No.
Yeah. Guys, Kubernetes is nothing but. Am I recording this? Yes. In a single line, we can say this as Docker container orchestration tool. What is the meaning of that?
Orchestration.
Yeah, I think I haven't explained I have given
Music director.
the song and orchestra with orchestra.
Yes.
So adding extra features for the container will be done by this Kubernetes, correct?
Yes.
Now, in a broader way, the actual definition, what will it do? It's an open source system which for automating deployment, first thing, deploying containers automatically, scaling. What is the meaning of scaling? Scale up
something.
Scaling up.
Scaling up, scaling down.
For example, guys, here scaling means, guys, you have, okay, in real time, do we create a single container or we will create multiple containers? What do you think? For same application. Definitely multiple containers with the same application. Why we create multiple same application?
For the performance and
Availability, guys.
availability. Yeah.
If something happened to one container, the answer can come from the other container. For that, we need to set up load balancer. If you remember, same thing on more than one component, you will set up a load balancer, and you will, traffic. You will reroute the traffic depending upon the health. Do you know that?
Yeah.
Same thing, guys. The same load balancing service. If you are using Kubernetes, no need to set up a separate load balancing service for the containers. It will be available automatically. That whole work will be done by the Kubernetes. So, guys, deploying and scaling means, guys, currently you have 4. You want to deploy the 5th one, 6th one, 7th one. If there is a necessity, Kubernetes automatically increase the number of containers we need for that application. So scaling up and down will also be done by the cluster. And management of containers application, everything will be managed by the cluster base. Everything will, if there is a container, how to deploy it, how to create multiple copies, replicas, how to manage it, how to create a load balancer for it. All this works on a single container or on all containers can be done automatically by this Kubernetes. Did you get my point? Understood?
Yes.
So this is the proper definition. In a single line, it's a Docker container orchestration tool. In 2 lines, Kubernetes is also known as 𝐂𝐻, is an open source system for automating deployment, scaling, and management of containerized applications. Then, okay, what does it contain? Kubernetes cluster consists of a set of worker machines called nodes. Very simple, guys. Okay, let me explain one picture. If you look at this picture, look at this picture. Is it visible?
Yes.
Here, the entire thing is my Kubernetes cluster. If you look at carefully, there is a control plane, and there is a cloud provider API, and you are having multiple nodes. These are known as nodes, guys. Nodes are worker machines. Node is nothing but a virtual machine, guys. It's a server. Okay, now, first let me explain about these nodes. Guys, generally where we have our containers,
Cloud.
okay, if it is on cloud, it will be on container registries, correct?
Right.
You remember we created one container registry, we deployed
Yes.
one application to that repo. And guys, we can have another VMs, correct? Windows VM, Linux VM. So you can have your containers on those VMs. Here, if you take initially, guys, want to manage any container, you need to create a Kubernetes cluster. And at the time of creating a cluster, you have to select how many nodes you need for that cluster. That means it is up to you. How many node is nothing but, guys, it's a virtual machine, VM. What is that VM? VM means, you know now what is a VM, correct?
Yes.
Now, each node here will contain two things, guys. If you look at carefully, one is kubelet, second one is kproxy or kproxy. So each node inside your cluster, guys, node is simple VM, that is it, server. Each node will contain these two things, guys. You can see kubelet, kproxy, kubelet, kproxy, kubelet, kproxy. And what is this? This is the agent. Let me explain. If you look at here, node, guys, initial 10-20 minutes, 10-15 minutes, there will be a theory, guys. We have to understand what is Kubernetes. Then we'll create Kubernetes. Look at here, node components run on every node, maintaining running pods and providing the Kubernetes runtime environment. If you look at here, what a node component do, guys, it does. There are two things it will do, guys. One is it makes sure, okay, first of all, guys, to explain this definition, there is a new word called pod. Can you see that? Okay.
Yes.
What is pod? Let me explain that first. Pod is nothing but, guys, the smallest, most basic deployable object in Kubernetes. A pod represents a single instance of running process in your cluster. Pod can contain one or more containers, such as our Docker containers. When a pod runs multiple containers, the containers are managed as a single entity and shared pod resources. Here, guys, very simple. I want to explain this with a picture. You know, this is a cluster. This is your Kubernetes cluster. I told you each cluster can have more than one node. Assume there is node 1. This node will contain kubelet and kproxy. Here, this is actually it's an agent. This is network provider. If you look at here, guys, what is the work of this agent? It makes sure all pods are running the containers. Then, what is pod? Pod is very simple, guys. Pod is nothing but each pod will contain at least one Docker container image. Guys, first of all, tell me, where is my application here?
Inside the container image.
Okay. Container image itself an application, correct? Image is nothing but application, correct?
Yes.
Where
Inside
is it?
the pod.
Inside the pod.
Inside the
Where all your images run, guys?
Inside the pod.
On a pod or inside a pod. Without pod, there is no container, guys. In your cluster, you could have n number of nodes. Each node will again contain n number of pods. Did you get my point? Yes, did you get my point?
Yes, but I have one question. So, like, so one pod belongs to only one node, or like the
No.
copy of that pod will be one goes to node 2.
You can Very simple, guys. You can, for example, you have one pod. Pod 1. It has .NET container. In the same node, you can have pod 1 clone. Same. Or you can contain this pod 1 clone in second node. Are you getting my point?
Yes.
So if you have same application, same .NET application, what is the advantage of having multiple pods?
Availability and failover.
Availability and failover. Remember, in real time, you will create at least 3 pods so that, you know, to increase the availability. That's it. And mostly, guys, what will happen? Example, your cluster is running one particular application which is there inside a container. Actually, inside a pod. Pod contains your application or container. We know that. If there is a need for a Kubernetes cluster, if there is a need that it is a peak hour, they need extra instances of the same container, it can add. Cluster can currently we have 3, it can add 4, 5, 6. So it is automatically scales up the container, these pods. And if there is a problem, for example, out of 1 to 6 pods, pod number 3 and 4 are taking more time to respond. That means you are having some 10 users, 5 pods. Each pod is serving 2 customers, 2 users. But 3 and 4, they are taking more time to serve those 2 users. There is a lot of latency for those 2 users. Then cluster, what it can do, it can kill those containers. Why cluster will kill that containers or pods?
To shift the traffic on pod first reports.
First of all, it should not be there. If it is not performing well, it should not be there, guys. If it is there, another user will be assigned, that user will suffer, correct? Are you getting my point?
Yeah.
So, guys, all these things will automatically done. And you know, you are having 10 pods. When there are 10 pods, you know, you definitely need a load balancer and you need to have an IP. You should have all those things. All those things can be configured as a service by this cluster, guys. Load balancing is also one service. You will never configure anything, guys. You see?
So,
right?
Yeah, so in a max, there would be one cluster and then pods, like whenever there is a traffic, so pods would be increased, right? Number of pods would be increased.
In reality, guys, if there is one cluster, you created one cluster in your cloud. That means you can deploy n number of nodes and you can deploy n number of projects as well. For example, if there is a VM, you generally create, when you create a resource group, that is for one project, correct? And it will contain all resources of the same project, correct?
Yes.
If there is another project, you will create another resource group and that contains other project details, correct?
Yes. So in ideal or in the real time, so there is one cluster should have the one application, right?
No. One cluster can have multiple applications, multiple projects.
Like environment is I may be a few stupid questions, but environment wise, if I go, so one cluster can have dev application, test application, and prod application.
Or it can have and it can have project ABC's dev environment, project XYZ test environment. Are you getting my point?
Yes. Okay. All
not
mix.
Yeah, cluster, it's a big thing. It's a very big auditorium, which can accommodate everything in it. Are you getting my point? Guys, cluster means it is not exclusively for one project. You just keep that in your mind. Did you get my point?
Okay, yes.
Yeah. Oh, you will not create 10, 20, 30 clusters. No, you will create maximum 2 or 3 clusters. And each cluster, when you create one cluster, you can manage multiple containers of different projects. Everything can be there inside one cluster. And you already have a node pool, multiple nodes. A lot of VMs are available in the same cluster. You can work with your containers using those VMs. Are you getting my point? Are you getting my point?
Yes. And generally, how many Docker container images resides inside the pod? Like
Generally, guys, generally one pod will contain only one application. One
container.
pod, one container.
Okay.
But you will create multiple replicas. That means the same application can be deployed on pod 1, pod 2, pod 3. Did you get my point?
Yes.
So you will this cluster will create multiple replicas in form of the pods. Each pod can contain the same application. Correct?
Can you please show any image,
Yeah.
Google image, like
Theory,
so-
I'll show in practical. Just wait. Try to understand this theory. Then we'll go and create those pods practically. Okay.
no architecture wise? I'm just asking.
Yeah.
Means like illustration of these pods and then container
Like-
images.
Yes.
Yeah. Architecture wise only. If I guess this is theory, na. When I practically create it, it will be more clear. Okay.
Okay. Yeah.
Yeah, just
Is
wait
that
for
sir, inside a cluster it's a node, and inside a node it's pod, inside a pod it's container. It's like
Yeah.
that.
Yes, perfect. That is what the next question. Inside a cluster, you can have multiple nodes. Inside your node, we can have multiple pods. Inside one pod, you can have multiple containers. But generally we use one container image. And who will manage all these pods inside a node?
Kubernetes.
This agent, kubelet agent, this agent. What is the work of this agent?
To make it
I manage all the pods
task.
All the pods it will manage. It will make sure.
inside the node.
Yeah, all containers are running inside a pod. Is there any pod which is not running a container? Then that pod needed to be removed. Okay. Some problem has occurred to that pod. It is not responding. So that is the work of this kubelet. That is nothing but an agent, which is there inside your node. Clear? Yes, clear?
Yes.
So if you create one cluster, that means like n number of VMs we can create inside the cluster,
Yes. You
and that automatically it will create a pod and container inside it.
Yeah, automatically means we have to we need to tell them how many we need. It does not automatically do that.
There is no count actually, any total number or something.
Generally, guys, I have created 20 containers inside a single cluster. That is the maximum number which I have seen. But there is no
20 containers inside a pod.
Inside a cluster, not inside a pod.
No, pod, after cluster it is inside, it is VM. Inside a VM it is pod. Inside a pod it is
the container. Correct. And here what I have done, have created one cluster with 6 VMs, 6 nodes. Are you getting my point?
Okay.
6 nodes. Each node, I created some 5 to 6 containers inside each node. That when I say 6 container images, I can create 3 pods for each container. Are you getting my point? So one node can contain a total 18 pods. Guys, just wait. Understood the basic theory of it? Guys, understood the basic theory of it?
Yes.
Let us see. Just here, remove this from. Okay, one last thing. Kuproxy is nothing but, guys, it will provide the network for that particular pods. So there, okay, how it just providing the permission for the end user to access the application which is there inside the particular pod of your node. So let us first practically create that. Then it will be more clear, guys. If I explain theory like this, it will just confuse you. So let us quickly create them. Guys, to completely deploy this project to this cluster, you should also know how to write YAML scripts. If it is a Docker container application, guys, what it should contain? The project source code, what should it contain?
Requirement.
Docker file, right?
Docker file.
You know, we need a Docker file for any application.
Yes.
It will contain steps like how to download the runtime for it and the working directory and the build commands, which will.
This Docker file is compulsory, but this requirement.txt is also necessary, right?
If it is Python.
It is Python, okay.
If it is
Else, if the code is not Python, then there is no requirement.txt.
there won't be any this requirement.txt.
Okay.
And here, in the same way, to work with this cluster, work with this Kubernetes cluster, should also have another file, another YAML file. If you look at here, guys, can you see the extension of this file? It is a YAML file. Can you read this? So we need to have this YAML file. So guys, I'll explain this later after I explain the basic things. So you should have this YAML file by using which you can deploy any container to your cluster. So guys, if it is only Docker container, if you have Docker file, that is enough. But if you are deploying, if you want to deploy the same application to the cluster, then you should have this YAML file as well. It will be known as EKS YAML file, guys. So first of all, before I come to this project,
just have a question. So without Docker container also, we can directly deploy the application on the Kubernetes.
what you will deploy, generally what you will deploy to the Kubernetes?
Container.
Container application loading up. Why we create a cluster? To manage containers.
Manage multiple VM. Multiple
Ah.
pods and
Containers, actually. Containers only, na, guys. Though it is running on a pod, what is our application?
container.
The container only, na? The container image, that is our application. To manage, deploy, kill, create.
So in a short, basically, application cannot be directly deployed on Kubernetes
without the Docker, no. Kubernetes will only work with Docker.
Okay. Or containerize any other containerized applications.
Yeah, only contains application, Kubernetes is there. You can't deploy a simple dotted application to Kubernetes. It's not possible.
Thank you.
Because it's a Docker container orchestration tool, na?
Yes, understood. Got it. Yeah. Thank you.
No. Let me come back.
So all files are required. This Docker file is also required. Then what
Yeah,
are the
everything.
case? All 3 files are required.
Yeah, this YAML file is required for Kubernetes, and that application should, yeah, because it's Docker, na? You're only managing your Docker containers. Na? Everything is Docker, correct?
Yes. Understood.
Yeah. Okay. So this we have already seen, that is Azure CLI command. We already seen it, correct?
Yes.
Yeah. Now, okay. Before that, we need to create. You know what?
We got some error while we are doing this login Python.
Yeah. Now we won't get that. So first of all, let me open the project. So here, first let me check. How will I check whether my cloud is connected with it or not?
Account. Is that account?
So first let's create this. What is this? What will this create?
Resource group.
This one.
Container registry.
Yes, yeah.
Container registration.
Yeah, Azure Container Registry, correct?
Right.
I'm creating this Azure Container Registry. Where I'm creating this registry?
In that repository.
Correct or not?
Yes.
Before that, what we need to do, guys, before you log in, we have just created, the container registry is also there. So if you go back here and look for registries, a new registry has been created with this name, correct? And it has an empty repo. Because nothing is there, correct?
Repo we need to create it.
Yeah, we need to create. Generally, it won't have.
That's manual. Okay.
It's an empty registry. It doesn't contain anything there. Correct?
It won't create a repository from Azure CLI.
We will create here. Just few minutes we'll create. Just wait.
Okay.
Now, what we're going to do first. Can you please tell me what will this do?
We'll compile.
It will compile, but yeah, it is compiling because it has a Docker file, and where it is creating a Docker image?
Registry.
No.
Repository.
The Docker desktop, it is. If you remember, can you please look at this picture? If you look at here, can you please tell me the difference between this one and this one? Is there any difference? By looking at the structure, you should tell something. This is registry on your cloud. How can I say that? By looking at the URL. This is Azure Container Registry now, guys.
Yes.
But this is my local registry, which is there inside my local machine. There is no URL. Can you see that? If you create a cloud registry, do we have a URL like this?
Yes.
This URL won't be there for our local deployed applications. Guys, here, this command, what it has done, this Docker build file, what it has done.
It has compiled the code or locally on your local machine.
Locally, and created a container in my local laptop, in the local Docker desktop, correct? Guys, correct or not? Are you getting my point? What will this do? The next step, what will that do?
It will run the application locally.
Locally running it. It is locally running, not related to the Azure cloud, correct?
Yes.
Guys, look at this. So you created this kind. Now we need to log this. And succeeded. Now, can you please tell me what is this? Can you please tell me what is this?
Deploying local Docker to cloud.
Deploying via tagging. Tagging means what is the meaning of tag? You tagged your local Docker image with the cloud image. Okay, tagged means you're on a tag. Now, what will this do, guys? The next step, what will it do?
It will push into registry.
Yeah, this one, after you tag it correctly, it is pushing the locally created image
To
into
the
the
registry.
Are you getting a point?
Right.
Now, if you go here and check, now you can see a repo there. Wait for a minute. Once everything is pushed, you should see a repo there with the name this repo 597.
Why we are logging into Python?
Because if you remember, if you want to push anything on the registry, by using the pipeline, do we need to create a Docker connection? Though you already have a service connection, why need to have a Docker connection? Do you remember when we used the pipeline, we have created a Docker connection to the container registry, correct?
Okay.
After that only we pushed the image into the registry, correct?
Okay.
So you have to log into the registry, then only you can push. You want to push something from your local machine to the registry. To do that, you should log into that or not. Guys, are you getting the point?
We have logged in already.
In this case, this Docker.
I already logged in now. Can you see?
This.
We have executed this command, guys.
So in this case, basically, don't we need to create a Docker service connection?
No, we are doing it from Azure CLI commands, only commands, no pipeline, nothing. Are you getting my point, bro?
Okay.
We are using CLI commands to push everything to the container.
Okay, so in this case, this Docker connection is not required.
Yeah, that Docker connection, what it has done, this login command is doing that.
Okay.
Understood or confusing?
In UI, this login part, where it is coming?
Yeah, that we'll see tomorrow. This is by using only CLI commands. Don't look at the pipeline UI.
No, if I see that GUI, I can relate it. So
here you want to tell here. I did not get that. What is your question? This is my repo. This is my image. If you look at here, this is my image, which I've just pushed. This is the one. This is my actual application image, which I pushed it from my local Docker desktop to this cloud.
So in this Python application is there, right?
Yeah. We just pushed now.
But before that itself, we have logged into Python. What is that? I didn't get
it. We logged into this registry.
Okay.
Before you push something, you need to log in.
Okay. We are logged into registry.
Yeah, log into the registry.
Okay. The name is Python, so I got confused.
Okay. Understood something, guys?
Okay, got it.
Okay, guys. Okay. Now come back to here. You pushed it. Now, can you please tell me what's happening here? What it is? Azure Kubernetes AKS, guys. Azure Kubernetes Cluster Service. This is the name. This is the resource group. What is this node count? How many node count we are having for currently? Only one. Okay. Look at this statement, guys. What I'm trying to do, I'm trying to create a cluster with this name, where in this resource group, how many nodes I want? One. And this is very, very important. We need to generate SSH keys for the authentication purpose. You will know why we need to generate. Then at the time of creation itself, I am attaching a registry to it. Why I'm doing it, guys? Guys, if there is a cluster, we already have a registry in my cloud, correct? Guys, let me explain.
But here, where are we creating pod?
Pod will come later, guys. We haven't reached till that point.
Okay. No, actually, we are attaching this ACR, right? So
this is your content registry we are attaching. Complete registry, not repo or not an image.
Okay.
We are attaching the registry.
Okay, not repo or not second.
Not image.
Not image. Okay.
We are creating a node first.
First, we are creating a node.
Cluster. First, we are creating a cluster.
Cluster node.
First, we are creating cluster.
Yes.
Then we creating
Node.
a node.
Number of your specific
Inside
number of
node,
nodes,
there will be a pod.
Yeah, inside node, there will pod will come later. Can you see? It will come, but later, guys. Just guys, let us go one after other. Please, you don't confuse, okay? Are you able to get it, guys? What I'm trying to do here? Is it confusing? Hello, guys?
Yes.
The words are a bit confusing, but yeah.
It's terminology. Yeah, it's
Yeah.
all new terminology, so we are confusing.
Yeah, if you practically do it, guys, it will be very simple. Now, for the first time, you are hearing all these things, so it may be a little bit
Sir,
different.
if you have any as you have restructuring, illustration or something, a figure or something, it will be easy to understand.
Yeah, but we don't have any figure, guys.
Or I'll just find out any in Google or something.
Yeah, I'll try to do that. So before that, let me.
I got it, but actually inside a cluster, there will be a node and multiple nodes can be done. Inside each node, there can be a multiple pods, and inside a multiple pod, there will be multiple containers.
Yeah, perfect. Yeah, whatever you just told, that is correct.
Now we'll do, practically we have to do that.
Yeah, practically, when you do it practically in your cloud, then it will be very clear for you. Okay. Yeah. Now, come back here. We haven't finished at least 50% of it, guys. We had to reach there. We just 50%.
So 50% of DevOps, sir.
No, Kubernetes.
Okay.
This particular project deployment. What are we trying to do? We're trying to deploy Python application inside a container that we have done. Correct.
Yes.
The Docker registry that is done. Python application, it is there inside repo, and inside the repo there is an image. It is there. After that, what you are trying to do? You want to deploy
Cluster.
Registry into a cluster. Correct. That is our intention, guys. Once we have this Azure container registry, we need to deploy that into that cluster. Once the cluster is ready, what you will do next? You need to create a load balancer. You have to create the pods. You need to configure how many pods you need, how many replicas you need for that application. You will see, guys. Don't worry. We'll go one after other. Can anyone explain me till this point? Because it will take some time to create a cluster. Anyone please explain from here to here. Anyone?
First we are compiling the Python code in a Docker to create an image, and we are creating the image.
Where we create an image?
In a VM.
No.
In a registry.
No.
Local
desktop. In your
Local
lab.
desktop. Okay, yeah. Then we have to expose it to a local desktop, which is the 5000 is the port. Yeah, and after that we are creating the registry inside a VM.
No. What is this?
We are creating a resource group.
Yeah, it's a resource group, guys. It's a resource group.
Right.
Name it this and in location this, correct?
In the location, yeah.
What is this then?
That is a resource group with registry.
No.
Account registry. ACR. ACR is a container registry.
Azure container registry.
Azure container registry.
What is the name of that registry?
Python registry 9997. Yeah.
Where are we creating it?
Inside a resource group.
Yeah, inside resource. Okay.
And after that, we are logging into registry.
Yeah.
Then we are creating. We are tagging. Yes, we are tagging that into a cloud. Now it is in a local now, and we are tagging it to a cloud.
Yeah, this is my local image.
And connecting it to a registry.
Yeah, this is my local image. This is my cloud image. So I am tagging. Once I tag it, then what I'm doing here?
We are pushing it.
Whatever the image which has been tagged with this particular cloud registry, that is going to be pushed into the cloud, correct?
Registry, yeah.
Then
we are creating a cluster and the node.
Okay. This is the name, 𝐂𝐮𝐫𝐬𝐿, correct?
Right.
With one node.
One code.
Yeah, this is, guys, these are very, very important. We will generate SSH keys at the time of creating the cluster itself in the cloud. And we are attaching the registry as well to my cluster, correct? Because if there is a cluster, do we need a registry? Yes. Cluster manages all the containers which are there in the registry, guys. All images, correct?
We can attach this container registry later also, right?
Yeah, later also. You can later also attach it. And what is this? Guys, once you have created that, you've created some SSH, you need to get credentials of this particular cluster. Because, guys, if you want to execute the remaining commands, you should have proper permissions. You need to have all certificates and secrets with you in your laptop. Then only you can execute the further commands. So you need to download that credentials. Get credentials of this particular cluster into your system. Wait, yeah, done. As you can see, particular. Can you see this, guys? It has been created with one notebook. It is ready. Now, guys, the most important part. Guys, till this point, this one, let's download this. Let me execute this. Let me execute this. When you execute, what will it do? It will download one config file, guys. Where? In this location. If you go there, you can see this is the config file, which contains some certificate, guys, some cluster certificate, authority, some the authentication which is required. Everything is downloaded to your laptop. Once you have this config file, then only you can execute the next steps. Did you get my point?
This file is the same which we in the earlier step we mentioned get SSH credential something.
Yeah, when we generated that with SSH,
Generated
generated and we just downloaded it.
Okay.
Into my system. Once I have downloaded, guys, now 50% of the project development is finished. The next important steps are this. These are the very, very important following steps. First of all, guys, this is the most, guys, this command will do everything, guys. The build command will create everything, correct?
Yeah.
Do you know? It will execute all the steps given in the, what is that, Docker file, correct?
Yes.
This single command, create repo, create runtime, create image, everything will be done by this command, correct? Correct or not?
Yes.
The same way, this single command, create pods, create load balancer, create everything. How this is important, the same thing, this is also that much important. So to execute this particular command, you should understand this YAML script, guys, how it has been written and where you have to make changes so that we can apply all the changes and we can create this pod, service and everything. So guys, yeah, that we'll see tomorrow. Today, guys, I might have confused you, but it's very easy, guys, actually. Very easy, but if you practice at least for once, then it will be easy. Did you get my point? Guys, did you get my point?
Yes.
Yes. So yeah, we'll do the exercise.
Guys, we haven't completed the project, have we?
No.
No, we just set up all our resources in the cloud. We haven't created any pod, any node, correct? We created node, but we haven't created any pods. We haven't created any load balancers. We haven't done that yet, correct?
Yes.
When you create pods, when you create load balancer, then only you will get an IP, and by using that IP only you can access.
Yes. So I wanted to ask one question. So in real time or at enterprise level, like is this the same process that normally we follow? Like on the Windows server, what would be the approach?
There
Like
will be 10 to 12 different approaches to deploy projects on Kubernetes.
Okay.
It is only way one. We can create pipelines. We can for each and every project, the implementation will differ. If you have this approach, you will only use if you are writing CLI commands. This is using Azure CLI commands to manage your containers on a cluster. This is only CLI method. Okay?
Yeah. So this CLI method only, about CLI method only, like if you are going with the Windows server, so the steps even same, right?
No. Guys, here, okay, what is Windows server? It is a VM only, guys.
Yes.
And what does it contain? Your container images, correct?
Yes.
And currently, what is this node?
VM.
That is only VM. Okay, bro, don't worry. I get your question. First, let me try this. You don't do anything, guys. You just create a registry and Kubernetes cluster. So guys, don't worry. We haven't completed.
Welcome to LWP Labs. Subscribe to our YouTube channel to view free Azure DevOps live classes. And for more videos like this, please contact the number shown in the description. Happy learning!